In this video, we're going to be making another graphics program. And this graphics program, I think, is going to be one of the more fun ones we'll make. You'll see by the end, but this is going to be pretty entertaining. Let's click the button that says New Class. I'm going to make this a graphics program, and let's call this BouncingBucur. If you are a Sacred Heart student, you might know that Mr. Bucur is our creative inquiry teacher. He helps out with robotics, and he also runs the CI classes. If you're ever looking for help to make something or in the shop, he's your guy. Let's double click and open on this. And I'll talk a little bit about what we're going to make. You might remember that in the last Java Intro 0 project that we worked in, I kind of snuck in this image of a grilled cheese. Well, this isn't going to be a grilled cheese that we're going to be using, but in this project, I actually snuck in an image of Mr. Bucur. So let's start by just putting that on the screen. Let's do gimage Bucur. Now, just to remind you of the language we've been using the past couple classes, let's think about what I've done here. We've now learned what classes are in Java. And in fact, I introduced kind of three big words to you, which were class, instance, and method. So let's use those terms to describe what I've done in this line here. I've created a variable, or would it be fair to say I've made an instance of the class gimage that's called Bucur. Now in the next line, let's actually initialize that instance or variable. Let's say Bucur equals new gimage. And I said I already snuck an image of him in here, so let's do bucur.jpg. And for now, let's just put him at 100, 200. And eventually, clearly by the name of this being BouncingBucur, we're going to make some movement happen. But for now, let's just add Bucur and see what that looks like. I'm going to compile. Let's go ahead and run this. And there we go. What a beautiful school picture he has. I think this is from last year. He looks great. Now, you've probably already guessed, but by the name of this program, we're actually going to have this picture of Mr. Bucur bouncing around the screen, almost like that DVD logo that everybody's so obsessed with. Now, he's a little bit large in this picture to kind of get some nice full movement around the screen. So let me actually introduce to you a new method that you've never seen before. If I want to change the size of this gimage, there's actually a method I can use to do that. So here, I'm going to type Bucur dot. And remember, Bucur is an instance of which class? It's an instance of the gimage class, which means if I type Bucur dot, what could possibly follow that dot has to be a method of the gimage class. And the method I'm going to use here is a method, like I said, you've never seen before, called scale. Now, the scale method actually allows me to either scale up an image, make it bigger, or scale down an image, make it smaller. If I want to scale an image down, I can put some decimal in here. Let's do maybe 0.7. And we can see what that looks like. Again, we know that scale is a method of gimage because to do Bucur.scale, that means this has to be a method of the class that this is an instance of, which is gimage. Now, let's see what that looks like. I'm going to compile. Let's run this. And there we go. He's a little bit smaller. You'll notice that I did put this scale after the ad, which might make some of you uncomfortable. Weirdly, what's going to happen is that my computer is going to add Bucur on the screen and then almost instantaneously scale him down to 0.7 so fast that we actually can't see the bigger image at all. But if this is making you uncomfortable, you can always switch the order and put the scale command there. That's totally fine. Now we know that our next step is to actually get him to move somehow on the screen. We saw this before when we did the cheese graphics program, that there's a command called move that I can use for a gimage. When we did it with the cheese program, we just did a for loop that went 100 times. We did kind of 100 moves. In this case, though, we kind of want this to just happen continuously. Now, the question is, how do I actually create a loop that just goes forever? There's a special kind of loop in computer science called an infinite loop. And the way that I do that is I can write while. And what I'm going to put in as the condition is something that is always going to be true. So there's a couple ways I can do this. You can put in some kind of mathematical statement that's always going to be true, like 1 is less than 3. That's never going to change. That's always going to be true. You can also literally just type in the word true. This is a loop that's never going to end. That's why it's called an infinite loop. Oftentimes when we're using an infinite loop to do some sort of animation with graphics, we'll call this our animation loop. So what am I trying to do continuously is move BouCur. So let's type BouCur dot. And again, what could possibly follow this dot is any method of the GImage class, since BouCur is an instance of a GImage. And one of those methods is move. For now, let's just move 1, 1, and let's see what that looks like. Remember, the two things that I have to give the move method are the movement in the X direction and the movement in the Y direction. Those are in pixels. So obviously I can't see you, but take your finger and kind of put it on the image of BouCur on your screen. And why don't you just drag your finger to yourself in the direction that he's going to go. I'm going to go +1 pixel in the X direction and +1 in the Y direction. +1 in the X direction is this way. +1 in the Y direction is down. So BouCur is actually going to move kind of in a diagonal line down and to the right. Now, if you remember from the cheese program, if we just do this, BouCur is going to move so fast that we won't even be able to see him go. So I do have to add in a command called a pause. This allows our program to slow down a little bit so that we can actually see what's happening. I'm just going to do a pause 10. We can always play around with that number. If I make this longer, he'll move a little bit slower. Let's compile this and let's see what this looks like. And there you go. There he goes. And oh no, he's gone. Now, for a program called BouncingBucur, he's not really bouncing. So how do we actually make him bounce? Well, I don't always want to be going 1 pixel down and 1 pixel to the right. It depends on actually where I am on the screen. What should happen as he moves down? Once BouCur hits the bottom of the screen here, shouldn't he actually kind of reverse direction and go back up this way? And if you think about it, what's actually changing there? Aren't I still moving in the same X direction, but now my Y direction is actually flipped? It would go from 1 to actually -1. So to make this a little easier, let's actually create some variables that are going to represent BouCur's kind of velocity on the screen in the X and Y direction. So let's do this. I'm going to do double velocity X. And let's for now just set this equal to 1.2. You know, being exactly 1, that's just so boring. And double velocity. Now we haven't used doubles all that much. I set this to 0.8. But just remind yourself, what is a double? It's just a number with a decimal. So there we go. We have our velocity X and velocity Y. So let's change this 1, 1 to now be velocity X and velocity Y. Now, that didn't fix anything. I just put variables in the place of where I had numbers before. What needs to change is that when BouCur hits the bottom of the screen, shouldn't that velocity Y actually become -0.8? So how can I actually tell that BouCur is hitting the bottom of the screen? Well, unsurprisingly, there's a whole bunch of GImage methods that you guys don't actually know. Remember, we looked at that ACM graphics library documentation just the other day, and there were a whole bunch of methods on there that you had never seen before. Now, because I've used ACM graphics quite a bit, I'm about to pull some methods out of my butt that you maybe didn't know existed, and it's totally fine that you didn't know those existed because we haven't really used them yet. What I really want to do is I want to see if BouCur's position has moved off of the screen. How can I do that? Well, I'm going to use an if statement. And let's try this. There's a command that actually lets me get the X and Y coordinates of an instance of a GImage. And the way that I do this is I can do BouCur dot get Y. Since get Y is coming after BouCur dot, I know it has to be a method of the GImage class. If that is now greater than the overall height of the screen, which I can actually just get by doing get height, Then wouldn't that mean he's gone off the screen? What do I want to do? Exactly what we said. Shouldn't my y velocity now be negated? This will make it so that if it was 0.8, now it'll be negative 0.8. He'll now be going up. Let's see if this solves that problem. Let's close out and do this, and let's run it. All right, there he goes, there he goes, there he goes. Oh, goodness. And all right, sort of. Now, he did bounce, but I didn't really love that because it wasn't super satisfying. What do you think get y is telling me? It's actually the y coordinate of his top left corner. Now, if we think about the way that this program works, don't I actually want to check when the bottom of the image is hitting the bottom of the screen? So if get y tells me the top left corner, don't I actually care about when that coordinate kind of plus the overall height of the image is off the screen? Here's some new information. There's actually a method called getHeight for a G image. And again, how would you know that? Is that this actually exists in the G image documentation, which I'm very familiar with, and you are now getting more familiar with. So let's compile this, or close out of the window that's running, compile. Let's run this. And hopefully this will make the bottom of the image hit the bottom of the screen. Now, why does he still go off the right side of the screen is because I probably need an if statement to check if he's going off the right side of the screen. It looks like I might have 3 more if statements to write. I need kind of one for each side of the screen overall. Let's do this next one. If, how can I tell that he's going off the right side of the screen? Will that be the x coordinate or the y coordinate? It should be his x coordinates. Let's do BouncingBucur.getX. And remember, get x is now going to be the x coordinate of which part of the G image? It's the top left corner still. We don't want the top left corner to be the thing that's traveling off the side. We actually want it to be the top left corner plus the width of the image. We want to check the rightmost side of the image. So let's do plus BouncingBucur.getWidth. If that is greater than the width of the screen, then it's not my velocity y that needs to flip. Now it's my velocity x. I would be going this way. I need to now be going to the left. So how I'm moving in the x direction changes. So let's say velocity x equals minus velocity x. And again, let's just check to make sure that works. Let's close out, let's compile, and let's run. There we go. He's going down, and boom, amazing. And boom, amazing. And oh no, he's going to leave forever. Goodbye, Mr. Bucur. 2 more if statements to write. And in a way, these 2 are a little bit easier. So, how can I tell if Mr. Bucur is going to go off the top of the screen? What's that if statement look like? First, is it the x or the y coordinate? It should be the y coordinate. And what is the top of the screen? It's not the overall width. What coordinate is that in our coordinate system? Isn't that actually the kind of y equals 0? So don't I want this if Bucur.getY is less than 0? That's going to be an issue. Now, why can I have this as just, why don't I have to add the extra get height? Is because in this case, we care about the top of the image hitting the top of the screen, which already is the coordinate of the get y command. Now I'll do same thing, velocity y equals minus velocity y. And let's just do the last if statement. It's going to look very similar. If, this is the left side of the screen, Bucur.getX is less than 0. Let's do velocity x equals negative velocity x. And let's compile this. Let's run it. There he goes. Let's watch him bounce around a little bit. Make sure we've done all of our if statements correctly. Looks good, looks good. All right, and it looks like he's successfully bouncing off every part of my graphics window. Again, using the terminology we've been using this whole time, we know that these methods, get X, get width, get height, and get Y, these all are methods of the G-image class. Because I am constantly using that pattern instance.method, this isn't going to go away. And again, we've been using G-image this whole time. A G-image itself is an abstraction, and we can use it because we understand instance.method. In a way, you can think of this dot almost like an apostrophe. We're looking at what is Bucur's x coordinate? What is Bucur's height? I could make a little joke about that. I'll refrain. What is Bucur's width? Definitely shouldn't make a joke about that. How much do I want to scale Bucur by? You can see how that almost acts as like an apostrophe S in the terms of the English language. Now, I want to dispel one big thing here. Like I said, in this program, I was kind of pulling a bunch of these methods really out of my butt and really out of the documentation. They are written down somewhere. There are many people who come into computer science classes thinking, oh gosh, I'm going to have to memorize all of these different commands. And that's totally not true. You don't have to remember these because they exist in the documentation. And also because I'm here to help you out if you do forget, is it get Y or is it Y or Y coordinate? I would always tell you. You don't have to memorize these methods. But what you do have to know is the format to be able to use them. Again, I'm hammering it in, but this instance.method. This won't actually be the last we see of BouncingBucur. In the next video, we are going to come back to this program to fix it up a little bit, but a little bit after we see a different example that will introduce a new concept to allow us to decompose this program in a really nice way.